Can I get all the panelists on board? All right, can I have a nice smile from everyone? I'm going to take a nice print screen. Okay, done now. I took that. Okay, I'm going to save that. And so thank you for people who have registered and now are attending the webinar. I'm going to now open up the webinar in this moment, and I'm going to start with my presentation. I will ask the panelists if they can actually now stop their video as I speak and present, and then we will have Bob coming after me, who's going to introduce the panel and start the presentations. Thank you, everyone, for attending the webinar today. It's a great time to have back the second of the series of webinars on the moon. And this is about lunar communication systems, which will be deployed and utilized over the next few years to connect to the moon and back to Earth. So I will introduce you the webinar now and the Access.Space Alliance. So the Access.Space Alliance is a alliance that supports the small satellite and new space sector. And the agenda today for this webinar is as follows. We're going to have this introduction, a presentation from the panelists, about 5 minutes each. There are 6 panelists. And of course, we have also another co-host of this webinar as well. And then we will have a panel discussion where the co-host is going to lead discussions in this panel. And then I will come back and lead the question and answer session at the very end. Please note that the recording and also this presentation is proprietary and copyrighted by the Access.Space Alliance. It will be posted on YouTube, the recording. And if you wish to make reference to what we're going to discuss today and the videos from the panelists, please do mention that you have this information from this webinar, as I will show you a bit later. The other last point is that we have a new structure for the Alliance. So we've been now up and running for the last 1 year. And if you would like to find a bit more information on the Alliance and you would like to join us, please email me or go on our website and join the Access.Space Alliance. I would like, first of all, thank 2 companies who have volunteered to sponsor the webinar today. The first one is Comstar, Space Communications, with Bob Brumley, our co-host, who is the chairman and founder of Comstar, and Ron McCandless is the customer commercial officer, who will be also making a presentation during the webinar. Thank you very much, Comstar, for your sponsorship. Our next company who has actually volunteered to sponsor the webinar is Thales Alenia Space UK. Remi, Challamel, the sales and BD manager, will be also presenting today during the webinar. And we will hear more about their mission and their infrastructure and architecture for communications to the moon as well. Thank you, Thales Alenia Space, for your sponsorship. The Access.Space Alliance is consisting at this very moment of the executive team between Betty, who's the founder of the Alliance, myself and Christian are the co-founders and directors of the companies. And we are running the Alliance from the UK, from France, and from Germany. However, we note that the Alliance is an international organization and we accept companies in the sector from all over the world. We have been formed in 2019 as a non-for-profit association for the small satellite sector. And our mission is to create an environment that allows entrepreneurship to thrive and prosper. And we have now started to have our formal membership from January 2021. So far, we have actually 41 companies today and universities that have joined us. If you wish to have more information, just please inquire with myself. In fact, our activities this year is a broad range of things like committees. I will talk about on the next slide. We're also organizing roundtables, talks, lectures, and also a conference at the beginning of May. A conference will be on a day and a half, in the morning and the afternoon session, so we can get people from the Americas as well as from Asia on board during the conference time. We will also holding advice bureaus for the members, for those that are new in the sector that require advice on any issues, anything. We will be holding these bureaus to help the members of the Alliance. We will also be attending international meetings and conferences as we need. And as I said earlier, we will be having our conference in beginning of May. We moved it by 2 weeks now. Instead of April, will be beginning of May. If you would like to access the old recordings of the other 25 or so webinars that have been broadcasted over the last 1 year. In fact, the first webinar was done on the 8th of April with Bob, myself, and others who presented their companies. So I will provide you with these slides, and on the slide you will have this link on YouTube. Otherwise, just search on YouTube Access.Space, and you will find the webinars which you can watch freely. The committees that we have so far created on free space optical communications, one on regulatory and space policy, next one on lunar deployment committee, and then we also recently created a finance committee for members only. And they will also have additional committees and also other activities this year as well. If you wish to join us and then follow the committees, please let me know. There's my email. Today's webinar has been registered by 188 individuals from basically 43 different countries. Here you have a list of countries from all over the world with the statistics of how many people from each country. Of course, as usual, majority of people usually are from the United Kingdom. There's a big range of activities happening in new space and the small satellite sector, which makes it the reason why we have a lot of people from the UK attending as well. Of course, we as an association, we are actually based as well in the UK, and we know the industry quite well. We also have US, India, quite a few people, and then you see as the numbers lower, we go to countries with only one participant from country actually is attending today. In terms of distribution, you'll see that most of the people are coming from Europe, about 66%, about 17% from the Americas, both North and South America, as well as then APAC, Middle East and Africa are present today as well. In terms of, for just your interest, a number of companies versus size of the company, collect the statistics of also the size of the company. A lot of the companies are in the 1 to 20 employees. And then, of course, there's a range of distribution also for companies slightly larger. I have to say that in the past, we had less than 10 companies above 21 and above with size of the company. Today, we have quite a bigger range, even larger companies, medium-sized companies like 500 to 1,000, for example. It's about 18 to 19 companies attending the webinar. So the interest in lunar communication is also interested. I can see not necessarily only from small companies, but also by medium-sized companies as well larger companies on the range of 10,000 and plus employees. I would like to remember Chuck Laura. Unfortunately, I learned last night that he's passed away, and he was a friend. We worked together in a few projects, and it came to a shock to know yesterday that he's passed away. And just want to remember Chuck as a space entrepreneur and activist for what he's done to the sector and for us in general. And now we begin the webinar. So I'm going to pass the, I don't know how you call it in English. You pass the
virtual baton.
Baton. In Italy, it's something different, which I forgot what it's called as well. The baton is passed to Bob. Bob, it's all yours now to present his six super panelists that we have today to discuss about their communication systems for lunar communications. Thank you, and I'm going to now hide away and come back later.
Thanks, Tony. Appreciate it. We've got a really great lineup of panelists today on what we consider a very interesting topic. We're all excited about what is happening on and around the moon in its development of humankind returning to the moon. Specifically, the Artemis program and the international partners in Artemis, as well as what the Chinese are doing on the dark side of the moon. It's just terrific to see all the activity and the interest, and quite candidly, the opportunity for commercial companies, smaller companies, to participate in this adventure and this great economic opportunity. The lineup today is reflective of that. We have large companies and we have small companies. We have entrepreneurial companies and we have divisions within large companies that are doing things entrepreneurially. The lineup, essentially, we're going to start with Nokia and their well-publicized relationship and project with NASA on testing and demoing a 4G transmission on the lunar surface. We will then roll into ESA to discuss about their programs, particularly the Moonlight program, constellation of planned satellites around the moon for communications direct to the Earth. Comstar, which is a commercial company located as a data relay satellite at L1 to relay between the Earth and the moon, both RF and optical communications for commercial and government users. We have the Space Ultra, which is basically proceeding with another relay constellation around the moon called Harmony. Some of you may not have heard much about it. It's pretty exciting. It is, again, intended to relay at a LEO orbit around the moon. We have SSTL from the UK that's going to be discussing their groundbreaking project called Pathfinder, which is, again, is a relay, more than a demo when you hear Nelly talk about it around the moon. And then finally, we have Thales Alenia Space that's going to talk about its migration of its geo systems in support of programs like Gateway, and particularly about its space platform, the NEO. So with that, I'd like to start with our representative from Nokia, and particularly from, hold on a second, I want to pull this up, from Nitin Shah. Nitin has a fun fact relevant to his background. He is the inventor of what is referred to as the airplane mode on our phones. And I have to admit to you, I don't know how many times I have had problems with getting the airplane mode off on my handset. He's been with Nokia a significant amount of time. He's a holder, I believe, of 13 patents at not only at Nokia, but his past employment in other firms. Nitin, I'm going to turn it over to you so you can talk about Nokia's program.
Thank you, Bob. So again, my name is Nitin Shah. I'm with Nokia Bell Labs based in Silicon Valley. And today I'm going to tell you about a technology demonstration that we're planning for wireless communications on the lunar surface. Okay, so as Bob mentioned, the project that I'm going to talk about is sponsored by NASA. So NASA has a program called Tipping Point from their STMD division, the Space Technology Mission Directorate. And last year in 2020, they announced solicitations for technologies in a variety of areas, but one of them was for lunar surface innovation initiatives. And what we did at Nokia Bell Labs is submitted a proposal to utilize the LTE 4G technology that is prolifically used on the Earth today for proximity communications on the lunar surface. As a result of that, back in October of 2020, we were selected into this program, which is sponsored by NASA. So the Tipping Point program is intended to foster the development of space capabilities for future missions. But this very much is a technology demonstration that we're doing as our first endeavor. So this slide that you're seeing is a little bit more detailed. So we are the prime contractor to NASA for this program. So basically what we're doing is taking what we call commercial off-the-shelf hardware and software, which is part of Nokia's 4G product line, and then adapting it in numerous ways for a space mission. So all the harsh attributes of space, including all the mechanical, thermal, the launch, the obviously wide temperature ranges on the moon itself, as well as then radiation and many of the phenomena that we will encounter as we launch this and land it on the moon. So basically what we've done is taken conventional off-the-shelf commercial technology and adapt it for this lunar mission. Our partner in this is Intuitive Machines. Intuitive Machines, some of you may be familiar with, is a company based out of Houston, and we're basically a payload on that machine. And they have a lander called the Nova C, which will be the vehicle by which we get our LTE network onto the lunar surface. And then also we have a rover, meaning a small vehicle on wheels, which will be able to go some distance away from the lander to illustrate and measure the performance of this wireless network on the lunar surface. So if we think of the concept of operations, firstly, we're going to land in late 2022, and we're going to land on the South Pole or close to the South Pole, near the Shackleton crater, actually. So our basic objectives are, firstly, to integrate our technology, the network assets, onto the Intuitive Machines lander. And we've selected a rover now, which will be able to traverse over the lunar surface, and really very similar to us having a cell tower on the Earth and then having a mobile phone on a car or on our person. We're basically going to emulate that, but on the moon. The link back to the Earth is a conventional link that we're leasing through Intuitive Machines. And I'm actually very excited to listen to some of our colleagues here, because if we are able to deploy this network based on LTE 4G on the moon, we still need connectivity back to the Earth, whether it's using the orbital networks, which will be in the moon, around the moon in the future, or these relay networks, which will then allow connectivity all the way back to the Earth. So basically, after we deploy the equipment, we establish the LTE network on the moon, we'll be able to collect a ton of data. And basically what we want to do is publish all that scientific data to enable the advancement of the technology readiness level, which is the objective of this NASA-sponsored initiative called Tipping Point, but also then open the door not only for 4G, but the future evolutions of mobile communications, which includes 5G networking for communications with certainly humans, but things on the lunar surface as we move into the next few years. So with that, I'll conclude. And again, thank you very much for having me on this conference.
Thanks, Nitin. I appreciate it. And for the audience, we're going to have a roundtable discussion with this group following their brief introductions. And then we're going to have a Q&A session open to the audience. Moving on to our next presenter is Fabrice Jolly, who is head of Future Telecom Program Consolidation at ASA. I think the fun fact in Fabrice's background of relevance to everyone here is he's in charge of a team focused on the initiation, technical, and consolidation of buildup of new telecommunications satellite systems and projects, including public-private partnership programs for the benefit of ESA member states and the SATCOM industry. In other words, Fabrice is the guy to call if you have a great idea that you think that ESA might be interested in, and that you're looking for partners, either public or private. He should be the guy you ought to give a call, and he can facilitate, I would assume, those relationships, or certainly know someone who can. With that, Fabrice, I will turn it over to you to talk about Moonlight.
Okay, thanks very much for these nice words, Bob. Probably painting a nicer picture than the real person, but thanks nonetheless. So very briefly, we have 5 minutes, so we'll give it 5 minutes. But I think it's worth spending the first 2 minutes of this to spend a little time on setting the scene here. The scene is very much with the moon right in the middle of it, and the moon, which has been instrumental to life on Earth. Some people say even that without the moon, there would be no life on Earth. And the moon is actually about to take yet another key role into the history of humankind. And that is to become basically the perfect laboratory, the perfect platform for experimenting and developing all the new technologies that mankind needs to develop in order to go out in space. And I would say that the first presentation already of this panel is a prime example of that. So basically, we're returning to the moon. But this return to the moon is in many ways very different from the first time we went to the moon, in that it's not about agencies, national agencies checking billions of dollars to plant a flag on the moon. It's very much about returning to the moon, but it's about staying on the moon. And I think you probably have heard the mission statement of the Artemis program with the boots on the moon by 2024. So that kind of sets the scene. So it's all about missions which have to be cost effective and have to be sustainable. So it does need to make sense that we can sustain those missions from the cost point of view and operation and so on and so forth. And one way of achieving that, and the agencies are very conscious of that, is and achieve the cost effectiveness is actually to work in partnership with the private sector. And I think the prime example is one of SpaceX, for example, with transportation. So it's all about, let's say, outsourcing some of the key functions that are absolutely needed, like commodities like we have on Earth, which is water, gas, and electricity, and make those possibly the topic of the subject of a service to be provided by private companies. And in doing so, we are basically opening up the notion of what we call the Lunar Economy. And my presentation doesn't go okay. Where we have the opportunity to share the burden of the infrastructure and of the cost of the operation between the public and the private, and at the same time open up some actual real business opportunities. And I think this term of lunar economy is one that may sound a bit surprising to start with, but when looking at the details, it actually makes a lot of sense. So now zooming a little bit more into the topic of moonlight. Moonlight is very much focused on one of those functions that I mentioned before, and those functions are communications and navigations. So we've already established there's going to be a wave of many missions going over the moon. Each of these missions will naturally need communications, and they will naturally need to navigate around and on the moon. And the idea is that all of these missions are currently not relying on having an infrastructure able to provide those, and therefore catering for their needs. And that means each of these individual missions have their own communication means and navigation means, and that is quite simply just not an efficient way forward. The idea, therefore, is to, let's say, aggregate all these needs and outsource it, and put in place, let's say, an infrastructure which will allow a service to be provided to all those missions. In terms of the missions, will be more cost effective, and hopefully this will even contribute to, of course, this concept of sustainability on the moon. So zooming a little bit more now into the moonlight of ESA, the European Space Agency. So I'll just read out the kind of the mission statement here, which is to enable the implementation of Europe-led private delivery of communications and navigation services that will support the current and the next generation of institutional and commercial lunar explorers. So it's a quite long-winded statement, but there's a few basic concepts in here. And I think maybe that the one thing to understand is that moonlight is not about ESA building an ESA infrastructure owned by ESA, operated by ESA for the needs of ESA. It's about basically allowing a private entity to actually go into a partnership with us and take up the challenge of building an infrastructure and selling services, and not only to ESA, but to whoever wishes to have those services. And to conclude, in terms of the steps that we are taking on this particular topic, an initial step is already ongoing with the Lunar Pathfinder that Nelly from SSTL will explain to you better than me. And we also probably be announcing in the next few weeks the kickoff of 2 preparatory activities to look at the the full system itself. And we wish to do that very much in close cooperation with industry. And it's about finding out the user need. It's about finding out the infrastructure technical solution, and very importantly, understanding the economics of it in order to better define that partnership and find the right setup. As you may know, ESA is an entity that works in a 3-year cycle of financing, where all the ministers of the member states of ESA get together and put some money into the ESA projects and plans. And therefore, the plan here for us is to work with this industry for phase A, B1, the 2 contracts that we will probably be announcing soon, up until next year, in order for us to present a program to the Ministerial Council next year. And with this, I think I conclude. Thank you.
Thanks, Fabrice. I told everybody he's the guy to contact. We'll be happy to give you his private cell phone number later. Our next speaker is Ron McCandless. Ron is Comstar's Chief Commercial Officer. Fun fact about Ron is that I met Ron last year, and he is actually a very strong media person. And our conversations last year in the context of Comstar was really more interesting to hear Ron talk about media and communications opportunities on the lunar surface. In other words, different ways of companies being able to drive some economic return out of creative use of video recordings, pre-programmed media, rebroadcast from the lunar surface, even to the degree of things such as drone races on the lunar surface. The technical challenges associated with that are beyond me, but Ron, take it away on behalf of Comstar.
Great, thank you, Bob, and thank you, Tony, for sharing the screen. We had a little technical difficulties earlier, so we're going to put up some slides about our plans with Comstar. We went public essentially last June with an announcement that we wanted to provide end-to-end service to anyone in cislunar space who wants to communicate from the moon to the Earth and in reverse from the Earth to the moon. And we did a market survey last fall to look at the cislunar market, and it was really an interesting outcome, because we found a lot of opportunities and plans and use cases, to use that language, that we didn't really have a great handle on. And we saw that as people go and machines start going back to the moon from Artemis and other projects, that there is going to be a very high ramp up of activity starting in 2024, but really ramping up in the 2030s. So when we designed Comstar, the first segment, or the first part of that, is Comstar 1. You can see the satellite there between the Earth and the moon. It's intended to go in the L1, the Lagrange point 1 area in a halo orbit. So it'll be able to service the near side of the moon and both north and south poles. And everyone knows everyone's going to the South Pole. Nitin mentioned two of the machines has a mission there for NASA. Artemis is going to go there, but there's some talk about going to the North Pole as well. So Comstar will be able to see all those activities and landers and rovers and drones, as Bob mentioned, that are happening over the near side of the moon. And what's great about having Comstar 1 is it's going to be give the ability of companies such as lander companies, rovers, and eventually, once they're developing facilities and operations on the lunar surface, whether it be data centers and lava tubes or mining the surface for water ice or valuable metals, the opportunity to send data back in pretty much nearly unlimited quantities, because we're really gearing Comstar 1 for a 15-year shelf life, if you will, working out there in the cislunar space. And as you well know, the first 5 or 6, 7 years, it's not going to be a tremendous amount of data, but it's going to ramp up extremely fast after that. And we're designing Comstar 1 to handle that. In fact, we're going to have 10 RF bands capabilities. So if you do C, KU, KA, S, L, so on and so forth, you'll be able to use Comstar 1 from the lunar surface to Comstar. And then we're going to be really focusing a lot on optical. So you'll be able to really do anything you want optically from the moon back to the Earth. And interestingly enough, it's going to be able to go the other way. So if you want to do monitoring of equipment on the lunar surface or teleoperations, or fun things like lunar rover racing or lunar drone racing, we'll be able to do that using Comstar, the Comstar system. So Comstar 1 is the point of contact for anything coming off the moon or in lunar orbit to go back to the Earth. We're also, by the way, this is all sort of part of the whole plan of attack, is that we're also going to provide a box, if you will, like a modem. We're calling it Aurora, and it's in early development right now. That'll be able to go on landers and large rovers and facilities that'll be on the lunar surface. And Aurora is basically the ability to gives the ability to send data most efficiently and with great swap savings back to Comstar 1 and back to our network on Earth. So we're really looking to save companies that are going to the moon over the next few years the time and effort and mass and cost of developing their own communications capabilities, advanced communication capabilities, especially those involving video or just high data streams. And we're transferring that capability to us. We're removing the burden of developing comms. We're essentially a data relay surface that's going to go back to Earth. Now, how does that work going back to Earth? Comstar is a point-to-point and end-to-end capability. So it's not like we're going to just send it to a ground station and you have to deal with it. We're going to go from A to Z, or as they say in Britain, A to Z, and we are moving data from Comstar 1 to the Halo network. The Halo network is going to be a network of 12 satellites in MEO, Middle Earth Orbit. They'll be hybrid satellites, so be able to take RF and optical, and then be able to transfer that data back to stations on the ground. And that's provided by LaserLight, one of our Comstar consortium members. Why don't we go to the next slide, Tony, and then we can focus on the last segment here. So once it goes to Halo, it will be transmitted to our vast ground station network that we're developing right now. We have a partner, one of our partners is Atlas Space Operations, who's helping us develop the optical and hybrid ground stations, if you will, around the world that'll be able to carry video and other, again, high bandwidth data from the lunar surface back to Earth. What's interesting about the Comstar consortium is that we are we've already have agreements in place with the likes of Lumen and Orange and Equinix and CenturyLink that will take that data, store it in the cloud, do any processing that's needed, and then send it immediately to the customer wherever they're at via terrestrial fiber in a manner in which they define. So we're working already with companies that want to do that. And part of the effort is defining how you go from the moon to your PC, wherever the data needs to be. And we have all the partners in place right now that will be able to engage to accomplish that effort. So we're working very closely with all of our terrestrial as well as space partners to make sure that happens for a customer base. Just to tie it up real quick, we are working in conversations and in talks with the CLIPS winners so far, and others that are both going to the moon in the next 2 to 4 years, as well as a couple of others that are have more long-term objectives, like putting data centers in lava tubes and doing other things along those kind of lines. So we're working pre-subscription agreements with those folks as we speak. And eventually that will lead to service agreements and SLAs and things like that. So anyway, I'm going to tie it up, but I just want to let everyone know that we're working very hard to make it easy for you as a lunar, as a lander or as a rover or as any kind of lunar payload that needs to get data from there to back to Earth to whoever you wanted on Earth to see it and use it. And Comstar is going to facilitate that. And we're looking forward, and we're very excited, to work with anyone who has that interest. And Bob, I think that's my 5 minutes.
There you go. Thanks, Ron. I appreciate it. Our next speaker and presenter is Sebastian Stroll. He is basically in charge as CCO, in charge of all commercialization efforts for Plus Ultra Space outposts. Fun fact for Sebastian is the fact that he's also been in a satellite startup. I think that's the neatest part of his resume that I like. He supported the buildup of a startup from scratch, growing it from 6 to 30 employees and sending the first 2 satellites into orbit. That is Cleo Connect. So he's been out on the what I would call the bleeding edge of startup experience, particularly in space, and has succeeded at it. And he's going to talk today about Harmony, which is Plus Ultra's satellite relay around the moon. Over to you, Sebastian.
Many thanks, Bob. Many thanks, Tony, for inviting us. Hello all, great to have you here today. I'm very happy to be here today. My name is Sebastian Ströhl. I'm CCO of Plus Ultra Space Outposts, and I'm really looking forward to present you our company and our offer within the next 45 minutes. So let's right away jump into it. Plus Ultra was born in the pandemic early 2020. We are headquartered in Madrid, Spain, but already managed to grow to the German new space hubs, Munich and Berlin. Our focus is off-Earth infrastructure deployment and management, meaning we will not build assets, we operate them. So the second race to the moon has already begun, as all of you of course know. The moon is considered as the mankind's bridgehead for deeper space missions, for instance Mars, or as a blueprint laboratory for planetary space habitats. So over 100 moon missions are planned for the 2020s, together more than all historic missions combined, driven by various nations, space agencies, and as we learned today, a lot of private initiatives and companies. So the efforts to explore the moon have significantly increased because the moon is the place to develop new technologies and skills needed for people to explore space and reduce impact on Earth. So the new lunar economy is creating an emerging commercial opportunities for landers, robots, habitats, transports, science, and of course many more. Numerous new missions with various tasks are going to populate the moon within the next 10 years. And all of these missions face the same 2 challenges: a lack of proper communication and navigation. Currently, communication possibilities on and around the moon are quite limited regarding available capacity, coverage, service level, and the same applies, of course, to navigation. And that's what we heard back also from our customer and prospect conversations, and that's what we will offer as of 2024, lunar and cislunar communication and navigation services. That said, you can clearly see our focus. It is the customer. It is most probably many of you sitting here in the audience. And that's the good news for you. Our mission is our customers and their requirements. So what are the requirements and what have we collected so far and how do we plan to serve our customers? Let's start with the customer's needs for the next generation, like we have everywhere on the Earth. Why should moon missions have lower technical standards that we know from Earth? So the same applies for coverage, connection, navigation, and mission setup. So what is the current standard? That's quite poor, a few megabits or less, heavy and power-hungry equipment, constrained access, limited communication windows, constrained and imprecise navigation possibilities, and complex one-off missions. What will we offer? We'll offer 100 megabit per customers, light and efficient antennas, ubiquitous access, 24/7 availability, real-time and accurate navigation, and the whole thing as an end-to-end solution and service. So in a nutshell, here are the values for our customers: maximization of the return on investment, minimization of costs, simplified missions, maximization of access to the moon, minimization of mission risks. So that's how our comms and navigation infrastructure looks like. There's a high-speed laser communication line between Earth and Moon, 2 orbital planes, each plane 4 satellites. They are interconnected to each other to enable continuous service, and the whole thing with a very high service level. And here is our timeline in a nutshell. We have completed our preliminary design. We are now in customers' talks for further gather requirements and, of course, close capacity reservation LOIs. Nitin, you said you would need a partner, so here I am. We'll start equipment RFIs very soon. The first satellites is scheduled for late 2023. The first orbital plane will be complete in 2024 and already covering 80% of the moon. The second plane is scheduled in 2026, 2027, then offering 100% coverage of the moon surface and also cislunar. So this was it from my side, very short on what we are doing. Many thanks for your attention, and I'm happy to answer your question, of course, in the Q&A part of this webinar or also later on. Here's my contact details. Please do not hesitate to get in touch with me directly, and I'm really looking forward to hearing from you. Thanks a lot.
Thanks, Sebastian. Now I fully understand why your Leo constellation was so successful. Well done.
Thanks.
Our next presenter is Nelly Offord. She is head of business exploration for SSTL, Surrey Satellite. She joined SSTL in 2019 for the exploration business development unit. Her fun fact that I dug out is the fact that she actually started her career as a management and strategy consultant in the automotive industry. I find her transition from automotive to aerospace unique in our industry, and at the same time quite interesting. She is a strong advocate for what would be Pathfinder's goals. And Nelly, over to you. Tell us about Pathfinder.
Thank you, Bob. Sharing my screen. Hopefully it's showing now. No. Can you all see my screen?
We can see it, Nelly.
Okay, excellent. Hi, everyone. Thank you for the introduction, Bob. So I am working for SSTL, which is a subsidiary of the Airbus Group and leading exploration. I'm here to talk to you about SSTL Lunar and our project, Lunar Pathfinder. So starting with SSTL Lunar, which has a vision, ambition, and then the roadmap. So SSTL Lunar is a brand of SSTL. It's not a new company. It is the embodiment of our vision of what we want to do with lunar services. So our vision, which we have been developing for many years now, with the help of ESA and our partner Constellation Station as well, is to build a reliable, performant, affordable, and easy to use support services for lunar assets. We're talking here about communication, which is the main focus of Lunar Pathfinder, but we are also talking about navigation services. Two of the main obvious objectives of that is to make the far side and polar sides as accessible as near side ones for all type of lunar missions, but also, and that this has been touched on in several of our panelist presentations, is to lower the barrier to entry for lunar exploration, taking away the complexity, the cost, the mass of exploration mission when it comes to communication and navigation commodities, effectively. In terms of ambition, starting with the ambition for SSTL Lunar, but we want to be the first to offer off-planet commercial services to lunar assets. And I will come on to that with Lunar Pathfinder in a minute. For Europe and the UK, we've been working a lot with UKSA and ESA with the ambition that Europe will become the international hub for lunar communication and navigation. What does it mean here? It means that whenever communication and navigation services around the moon, and why not around Mars and other off planets is in question, the instinct is to come to European industry and European institution for it. And our roadmap for that, the first one is Lunar Pathfinder. Lunar Pathfinder will be operational in 2024, launched at the end of 2023, and will be the first data relay spacecraft. It is a commercial proof of concept, also a technical demonstrator, but it's more than anything else a commercial asset in service that we will be offering commercial service with. And then our ambition extends to a constellation. So the constellation, I've put a date here of 2030s TBC, but this constellation will enhance capability of the comms services, of course, but it will also support navigation as well as communication. Moving on to Lunar Pathfinder. So you can see on top the timeline of Lunar Pathfinder. I'm very excited to let you know that the spacecraft development has started. So the clock is ticking, and we are working as fast as we can towards a launch at the back end of 2023. The in-orbit delivery will be managed by NASA through CLIPS providers. Again, around the end of 2023. We will be operational in 2024, offering data relay services that will be available for commercial and institutional missions with 2 levels of service. I'm happy to give you information about the different level of service that you might be interested in. I've put the link in the presentation, which I think Tony will be sending, so you can go and have a look on the website and have a look at our user manual. It is based on a store and forward technology with 2 channels simultaneously available on the Moonlink, one in UHF and S-band, and the return to Earth is in X-band. The data rates are up to 2 megabits per second on the Moonlink. We will be also hosting a GNSS experiment for ESA, and we're very excited about that, because it will be the first step towards the navigation services around the moon. Obviously, with one spacecraft, it is limited what we can do in terms of navigation services, but this experiment will be a fantastic demonstrator. As I said, all the information is available in our user manual, which you can download from the SSTL website. And again, you will see in the data pack that you will receive, I've put here all the link to the press article that we've had already, and the Lunar webpage, and at the very back, my contact detail if you want to send me an email, and Jonathan Friend, who he's the engineer in charge for all the customer requirements, is there as well. So we're more than happy to welcome your questions. And that's it for me.
Thanks, Nelly. I appreciate that. I'd point out to the audience that we actually have a marketplace here now, because we have, of the presenters so far, we have 3 commercial independent communications systems that are being deployed in late 2023 and into 2024, at least their initial elements. And all 3 do something different. All 3 bring something unique to the marketplace, and all 3 also can be highly complementary to each other. And all 3 are generally commercial. I think that shows some green shoots in the industry, that lunar communications particularly has a strong and a future ahead of it. Our last presenter, but by no means the least, is Remi Challamel. And Remi, I know because Comstar has an LOI to purchase a bus from TAS UK, and Remi is our essential point of contact there for purposes of the Comstar bus. but particularly he is also, broadly speaking, pretty much head of everything with respect to institutional programs and business development for TAS UK. He has been a great help to us, and I'm so glad he had time to come on. So, Remi, I'm going to pass it over to you.
Thank you very much, Bob, and good afternoon, everybody. Thank you also, Tony, for the organization of this great event. So I am Remi Challamel, in charge of business development in Thales Alenia Space. So it's really amazing to be here today talking about moon programs and opportunities. The current decade will be the one in which mankind will set again its foot on the moon surface. And mankind needs to communicate. So which infrastructure could we offer to those future programs? I think that Fabrice, Bob, and Comstar colleagues make it very clear how promising the Lunarcom market will be, but also how mixed it is expected to be, involving both commercial and institutional stakeholders. So the question is, how could we serve this market? And in order to talk about that, let's start a journey from Earth to the moon and even behind, and to see rapidly what TAS could offer for our customer. So if we start with 400 kilometers far from Earth, this is where we have orbital infrastructure, ISS, and TAS built 50% of the habitable parts of the International Space Stations, including the cupola observation module and pressurized module of the resupply vessel Cygnus. But if we go a bit above, around 700 kilometers, 800 kilometers, this is where we have the big telecommunication constellations, Iridium, Telesat in the near future, and those constellations are key to enable to deliver communication all around the world. Then if we go a bit above, we have the MEO orbit with navigation satellites that we have built in the past for Galileo and past and future generation of Galileo. And then we have the Geo Orbit, where we have those big satellites, geo satellites, telecom satellites, providing very high throughput telecommunication. And then we have above, we have Moon, even Mars and beyond. And I will spend a bit of more time talking about that. So before focusing on what we could offer on the moon, let's have a rapid look on what we offer today in terms of telecommunication solution around the Earth. We offer either very high throughput satellites. We talk about satellites of enabling to embed 20 kilowatt power payload, 2 tons telecommunication payload. So it offers massive capacity and throughput to the payload provider, to the payload service provider. We have a second range of products that are that are ultra flexible. This is a space-inspired solution with a software-defined payload, offering a lot of flexibility to our customers. And then we have constellation solutions, paving the way to 5G, including advanced ground segments. when talking about constellation, I think it's worth mentioning, for example, that most of the telecommunication constellations flying and operational today has been delivered by tasks like Globalstar, O3b, Iridium, and in a very near future, Telesat constellation. Now, if we go above LEO, MEO, GEO, and if we go now around the moon, lunar and moon station is the next giant leap. So we are entering in the ambitious new era of men and women exploring our solar system and starting by the moon. Obviously, we have been key in delivering some infrastructure for the ISS, but our next target is really the moon, and TAS is currently a strategic partner to Artemis mission. But not only, we have been selected by ESA as a prime contractor of delivering two crucial elements of the lunar gateway. One is a IHAB module, International Habitation Module, and the other one is the Esprit module, which gather both the refueling but also the communication system of the lunar gateway. So we are going to provide those modules. We are going to provide those communication system for the lunar gateway. So I think that as a resume a bit, I would say that we can provide combined capabilities in telecommunication mission, but also we can provide deep space mission solution. So by combining the both of them, we are very happy to provide the right solution to our customers willing to deploy cislunar telecommunication services.
Thanks, Remi. We are now going to go into the roundtable discussion. And if Tony, you can put, except mine, if you can put everybody else's video on, I'm going to start by essentially asking some questions thrown at specific individuals to respond. And I'm going to start again, as I did before, with Nitin at Nokia. Nitin, my question is, what communications infrastructure would a full lunar 4G or 5G network require to connect the Earth, to the Earth or via relay systems? Can you share that with us?
Sure, absolutely. So starting with the 4G or 5G systems, as you probably know, the data rates which you can communicate with those systems today, and as they evolve, are in the tens or hundreds of megabits per second, and with 5G even gigabits per second. So for what I'll call proximity communications on the moon, we can get huge data rates. However, this also implies that because of the limitations of bandwidth between the moon and the Earth, because of the various techniques we've talked about, those are, even for one user, to be able to sustain that all the way from the moon to the Earth is very difficult. And so I think we get into an end-to-end architecture, which is really my response, which is we heard from Nelly about store and forward capabilities. We also then have relay capabilities. I think that we have to have essentially, I don't know if you call it cloud because it's on the moon, but essentially edge cloud and cloud capabilities on the lunar surface as well. The idea is therefore, firstly, to be very efficient in the use of communications based on size and power and so on, but also then be very respectful of the links between the Earth and the moon. And as you mentioned earlier, it's very exciting that there are these many different diverse techniques by which different types of communications can be conducted, because it's not just about bandwidth, but quality of service, availability, maybe critical communications, which may use various diverse paths, not a single one, in order to get back. So again, I think there's a whole picture around network architectures, where things are computed, where they're stored, and how they're communicated back. So it is a complex networking sort of solution that we have. Unfortunately, I mean, I think this community, and certainly at Nokia, we have the tools to be able to do that.
Thanks. It does underscore the fact that the moon is really the ultimate edge right now.
Right. Yeah. Yeah.
With all the elements associated with what the edge both down here and up there should have. So, yeah, great answer. Fabrice, NASA is, this is your question. NASA is planning an initiative for Lunarcoms around the moon, and actually on the moon, called LunaNet. Do you see any potentially overlapping initiatives to what Moonlight is doing, for example, and maybe some of these other companies?
Thanks, Bob. That's a very good question. This is a question we get asked very often. And there's a lot of possible confusion and misunderstanding on the intent of these various initiatives from various agencies. And I think the best way to answer that question is to actually quote some words which I found on some slides in a public presentation, which was a couple of weeks back, actually, which I attended. And this was a presentation from our colleagues from NASA, from the SCAN and network, where the guys actually pushing for this LunaNet initiative. And they said the following. They said LunaNet is not a particular satellite or a constellation of satellites, nor is it a project, a program, or organization. So what LunaNet is, however, is very much around the concept of setting up a framework, allowing standardization, allowing interoperability, being an open and scalable in terms of architecture, and basically allowing all different types of entity, be it commercial, in other words, private or institutional, to bring a node into an overall architecture. So it's all about LunaNet, from the explanation of our colleagues on NASA, is all about making sure that all these various initiatives and systems are taking care of being interoperable, so that they can operate in a kind of a harmonious and single way. So in this respect, actually, let's say the Moonlight initiative of ESA, which is opening the door for igniting a service by a private partner, is 100% complementary and compatible with that. And I would say, to a certain point, any initiative that is willing to be part of this effort of standardization and interoperability.
That's great. That means I'm not going to get nasty calls from NASA. That's super. Ron, your question with respect to Comstar is that, do you have it? Can you give us some examples? Because I know all the relay companies that have presented are having active conversations with potential customers. But can you kind of take it into more specifics, other than they want bandwidth? What are some of the applications they're looking for? You alluded to that in your presentation, but just give us the flavor that brings them into sharper focus.
Sure, Bob. I have a couple. One is a recent agreement that we've made with Ontario Tech. Dr. McGregor there has Artemis Astronaut Health Project that's going to be use basically a big data analytics platform. And to make that effective, for example, if you have astronauts on the lunar surface, to monitor their health, physiological and other clinical data need to be sent and need to be viewed and acted upon in near real time. And using today's infrastructure just doesn't really cut it for what they need for this Artemis Health project. So yeah, they're very much interested in using Comstar, because they can have instant or near instant, depending on the speed of light, of course, interactions with the folks on the lunar surface and monitor their clinical and physiological health in real time. So that's one example. Another one is that we're working with various CLPS lander companies to test out our Aurora payload, the modem and controller that's going to help with communications eventually to Comstar 1. But in the meantime, we can send data. For example, late next year, we're planning to test Aurora on one or more CLPS missions that will go to some of the satellites, the Halo network in MEO. And that will, we've heard from customers that will open up the opportunities for innovative and more data intensive payloads that they can fly and save swap at the same time. They don't have to worry about mass and developing technology on their own to attract those kind of customers. So Bob, those are a couple of examples that come to mind.
Great, thanks, Ron. And Ontario Tech, because it is public, is an example of local compute because because they're working with IBM as well on that project. Next, Sebastian, I've got your question. Do you need continuous availability with respect to your spacecraft when they're operating in short communications windows, or can you do basically bursty traffic?
Well, we see a continuous and ubiquitous availability of the communication and navigation services as a game changer. So we really focus on that. The operations teams will not longer need to schedule communication and orbit windows. They will always be online, and that will reduce cost and complexity of the missions, and will also, on the other hand, maximize the scientific and the commercial, in the end, return on invest, what is possible. So the same applies for the GPS-like navigation that will enable enhanced autonomy missions. So especially during orbital maneuvers, like landing or proximity operations. So the spacecraft will be able to monitor execution of its maneuvers and also apply corrections in real time. So instead of relying on Earth-based measurements, calculations, and commands. So that's also a very important point. So finally, we are, as I said before, we are used on Earth working with these kind of technologies. Why shouldn't we put it also there on the moon? It's feasible, and in order to really have a sustainable lunar economy that has all possibilities to grow, and be it scientifically, be it commercially, we really see this as a must-have.
That's great, because essentially what you're doing is you're eliminating scheduling, and you're going to an always on, always available service, which is a big leap for space comms. Yeah. Well done.
Thanks.
Okay, Nelly. I don't know if this is an oft-asked question or not, but you mentioned it in your presentation, so I'm going to ask you to clarify. Is Pathfinder a tech demonstrator, or is it actually a fully open for commercial business revenue generating opportunity?
Thanks, Bob. Well, it is both actually. So Lunar Pathfinder, and I forgot to mention it in the presentation. Lunar Pathfinder is realized in partnership with ESA, and we are very much helped by ESA to get this off the ground. So as such, it will be a tech demonstrator because we will show how the data can be relayed using a single spacecraft. At the same time, it is also a business proof of concept. So we talked about the lunar economy, the ability to demonstrate that there is revenue to be made from comms, and we will do our very best to not only demonstrate that we can make revenues from comm, but actually make a profit and be able to generate more a development of Lunar Pathfinder into a constellation at some point using this profit. So very much open to commercial business. We will be opening a tool on our website very soon where each of you will be able to go and put a few parameters of your lunar mission and understand what service we can get to you, approximately for what price, and then you will be able to engage into a discussion like any other commercial service. In terms of demo, just one point, I mentioned the GNSS experiment or demonstration. which is very much a tech demo in that sense. And I just saw a question around the use of L-band. This is a receiver demonstration that is handled by ESA, so there will be no emission of any L-band signal. It's just to prove that we can receive weak detection signal from Earth's GNSS. So that's a precision I wanted to share.
Yeah, we have a well-informed audience here, so
I can see that.
They're going to call you out, if you let them. Thanks, Nelly. Remi, last question, and this one's for you. What, just in plain terms, from telecommunications requirements, what do you think the kind of telecom services would you expect for lunar missions? And kind of use Gateway as an example, and what those customer requirements might be.
Okay. Well, as discussed with all the different participants of the panel, there will be a strong need of providing telecom services in the future. There were some article mentioning a mission data volume of tens of gigabit. That is a kind of need in the future. So in order to address those needs, we will need an infrastructure enabled to deliver hundreds of megabit per second. Now, it's true that there are currently already some plan, like for example, the Halo lunar communication system on the Lunar Gateway, which is an infrastructure that is currently under development in Thales. And this system is going to deliver up to tens of megabit per second. And this is what will be delivered from between Moon and Gateway. It's big, but maybe it's not big enough when we talk about needs between Gateway and Earth, or need between, let's say, lunar relay satellite and Earth. And this is where maybe a comparison with a capacity of a geosatellite could be quite interesting, because we have today some big VHTS satellites enabled to deliver hundreds of gigabit per second around the Earth when in geo orbit. But if you consider that the lunar distance is roughly 10 times more than the geo distance, that means that a link budget will be impacted by a factor 100, which means that those big satellites, if you fly them around the Moon, will be able to deliver in the order of gigabit per second. So I think that's an interesting analogy that shows how the kind of throughput that a system could deliver by using this kind of technology.
Well, you certainly convinced us at Comstar, because we've got an LOI to buy one of those big battleships from you. So yes, we agree with you. Tony, that concludes the roundtable. I'll turn it over to you for purposes of addressing questions from the audience. And I thank everybody for your cooperation on the panel. Appreciate it very much. Tony?
Thank you. I hope you can see me now. I think you do. And I'm going to start the Q&A session. So thank you the panelists. Thank you, Bob. No introductions on myself. You have no bio, so I'm going to, everybody knows me anyway. Don't have to do anything, Bob. Where are you, Bob? Can I see you? There you are. Excellent. Okay. All right. So you're part of the Q&A as well, Bob. So I'm going to look at the box below, start from the top. And I know that Jean-Luc Isler from CNES has been asking a lot of questions and has been actually providing a lot of information. Jean-Luc is concerned about radio astronomy on the far side of the moon and that this needs to be protected. Any views from any of the panelists about protecting radio astronomy on the far side of the moon?
Sure, we will.
Okay, maybe if I can interject, I think most of your, or all of your projects, at least for the next 3 to 6 years, 10 years, are going to be on the near side of the moon. So by mere physics, likely you won't be transmitting any frequencies on the far side, or if you do transmit frequencies on the far side of the moon, they're not going to impact the radio astronomy usage of the frequencies on the far side of the moon. Not that I'm aware there is a radio astronomy, let's say, receiver on the far side at the moment, but yes, there is some kind of a international treaty that requires protection of radio astronomy on the far side of the moon, and that frequencies on the far side of the moon will have to be coordinated somehow, agreed upon with the radio astronomer. I'm gonna go now to the next questions. Any views on that, on what I just said by anyone, Isa or anybody else?
Maybe I could just quickly compliment that there are some interagency advisory groups actually being in place, notably the IOAG, which is the Interagency Operation Advisory Group, with a specifically working group on lunar communication architecture. And I do believe, not being part of it myself, but I do believe that, talking to some colleagues, that they are looking at all aspects of the use of all the various frequencies across the spectrum, and then expect that that would be, of course, taken into account.
Thank you, Fabrice. Thank you so much. Anyway, I'm going to go to the next question from Francisco Periales to Ron. Ron, what is the expected launch date for the Halo network and the Comstar 1?
Yeah, thank you. Comstar 1 is looking to go fourth quarter of 2023. So we need the Halo network up and running and tested before then. So we're looking to do a series of launches from late 2022 throughout 2023 and bring up 3 or 4 at a time in a constellation of 12 satellites. And when I mentioned on, I think Bob's question or someone's question about testing Aurora on a late 2022 mission to the moon, we expect to have a handful of the Halo satellites up at that point as part of that whole test program. So,
thank you, Ron. Good luck with that. Best wishes. And now the next question is from the anonymous attendee, and the question is about whatever satellite constellations you are building, how many satellites will be in the constellation, and what size each of the satellites will be. Who's going to answer that?
Well, as said before, we are planning to have 8 satellites in 2 planes, and these satellites will be a few hundred kilos. So that's the current status we disclose.
Yeah, Comstar is a single satellite, Comstar 1. And as Ron mentioned a little bit, Lagrangian point 1, and it is a NEO 200 bus supplied by Thales Alenia.
Okay. Next question again from somebody else, anonymous attendee. Who are the expected customers for the orbital SSTL and surface-based communications from Nokia? And I'm going to finish the question. And how do you go about selecting the orbits in case for orbital and constellations, and selecting the landing locations in case of the surface-based communications? I suppose that those that are building a constellation around the moon, and also from Nitin and others that are actually doing communication architecture on the surface.
So this is Nitin Shah from Nokia. I can certainly address the surface communications aspect, which is, firstly, we're engaging initially in a technical demonstration. So it's really around technology and science, which is a project we have in underhand. On the other hand, what we're starting to see is the emergence of a number of companies which want to be the equivalent of a service provider that we would recognize on Earth. In other words, would want to provide combination of the networking capability to end-to-end connectivity, which includes the transmission back to the Earth, not just the lunar surface, and then also be able to encompass a very large range of applications and devices that would be provided onto the lunar surface. So again, in terms of customers, you mentioned programs like Artemis, and there are numerous private endeavors on the lunar surface planned as well. So those, I think, are the end customers, which would consume the devices, the applications, and the services. And then what we see, as I said, is this layer of service providers such that those end customers would not have to go buy their own infrastructure, but basically use this fully sort of interoperable infrastructure, very analogous to what we have on the Earth today.
In terms of constellations flying, satellites flying around the moon, the question is about the type of orbit.
Yeah, I think I will take this one, Tony, because I think it's the one for SSTL. The expected customers, very much along the line of what Nitin already explained. It's about the commercial and institutional lunar assets who want to have a solution for proximity communication and relay back to us. So I'm not going to dwell on that one. The orbit question has been very kindly answered by the following question, which is that Lunar Pathfinder will be in an elliptical frozen orbit, which privileges the South Pole, because the South Pole of the Moon has been clearly more popular with exploration missions so far. So we've decided to privilege the availability of the spacecraft over the South Pole, and the frozen orbit is to keep the satellite alive as long as we can for the 8 years of operational lifetime.
All right, thank you so much for that. Next question from Konrad Nieradka. Nitin, it's for you. How are you dealing with the latency and interruptions typical in space environment when using and running TCP/IP based LTE networks? And are you employing any of the DTN protocols?
So firstly, we are obviously very aware of the DTN protocols, but we're not using them, at least for the technology demonstration that we're planning in late 2022. What we are doing is we've got an operations center which is on Earth, but the networking equipment and the devices we're deploying or planning to deploy on the lunar surface have their own individual software agents, which allow for the latency or potential even disconnectivity from the operations on the Earth. So in a terrestrial system, obviously our operations system is directly connected to the whole network all the time, and it's highly reliable. So we've actually done a lot of work on the software applications and operations side to allow for sort of pseudo-autonomous operation, even in the case of a fault or a reset, where normally you'd send out a technician to fix something. Here, we've added a lot of technology to be able to have these systems operate autonomously for those exceptional circumstances that you just described in the question. Yeah.
Thank you, Nitin. Next question. I'm not sure if any of you are able to answer it, from Attila Smatas, a good friend of mine in Geneva, based in Geneva at the ITU. Who is coordinating the lunar communication? Is it SFCG, this group of space agencies who get together once a year to coordinate space-based frequencies, or is it based on ITUR ready regulations? Anyone has any answer for this? No.
Should know this, I guess, but yeah, indeed, it's. I'm aware of these two groups, but I wouldn't be able to tell which one does the job.
Okay, perfect. We don't know the answer to these questions. I do presume that everybody is following the ITU process of making a satellite filing, and then through the satellite filing procedures, they coordinate the systems with other proponents. Thank you, Attila. Next question will be from Konrad again. We have 3 minutes left, so I'm gonna just speed up here. Ron, Comstar 1, does it mean that you're planning future additional satellites to replace the single satellite, or you want to have additional satellites to actually work together?
Well, that's a very good question. Now, Comstar 1 has a 15-year design lifetime. And what we're going to do is we're going to, it's really going to signal that we're going to look at it as we go down the line and decide what additional assets we need to put into place. So I don't think Comstar 1 will be a lonely or only child eventually, but it's going to be a few years off.
Thank you, Ron. I'm going to, well, I'm trying to read the last question. It's quite long, and there are two of them. So it's all about ITU, the current regime authorizing and licensing satellite broadcast services for these hybrid Earth-Moon satellite communication, national, international level. I don't think actually anybody has thought about this, and maybe we have to create a new United Nations of the Moon, and then we can then discuss this.
Maybe I can take this one. We of course have considered this because we know it from the LEO world that coordination is very important, and we of course will start this process with the ITU and whomever. We need to coordinate because you cannot just leave it like the Wild West. You have to coordinate and align here. So that's what we are aiming to, and we are about to already do it.
Thank you, Sebastian. Anybody else would like to say something on this? If I can put my 5 cents, some people say 2 cents, some people say 1 cent. Let me put my 5 cent answer to this. I do believe that the current ITU radio regulation do not cover the use of frequencies on the moon or around the moon, and that basically there might be a need in the future for the radio regulations of the ITU to be upgraded and include maybe a service area 4, which is the moon and the outer planets. Or otherwise, as I was saying earlier, maybe we can create the ITU of the moon. I say United Nations, I said ITU of the moon, and I'm ready to become the Secretary General of the ITU of the moon as the first one. Thank you for your confidence vote. Next one would be again from Vinicius. Long-term sustainability of space activities in the lunar orbit. As we all know, the common legal and regulatory regime falls short of assuring the sustainable use of space, with no legally binding norm at the international level for the protection of the space environment. The instruments we have available are not legally binding in nature and designed for the orbital and atmospheric conditions of the Earth. How have these issues been addressed? Maybe IADC, which was already mentioned, for future commercial lunar missions. Are you going to actually push the satellite to actually crash on the moon, or are you going to actually eventually at the end of life to speed up and move it around the planets, in the interstellar space? Anyone thought about this?
Well, we have thought about it for Lunar Pathfinder as well, and we are following the NASA regulations. So we're working with them, and they'll tell us what we should be doing, and then we'll take a view with ESA as well. So we're completely guided by the institutions here.
Yeah, it's a major issue, especially for those orbital resources around the moon and interstellar space, and also Lagrangian points, to make sure that any satellites at the end of life is decommissioned in a proper way, not to interfere with future missions that might actually want to hold the same position later. That's something that everybody needs to think about. So let me congratulate Bob for putting together this exquisite panel of people from all over the world who are thinking outside of the box to deploy future communication architecture from the Earth to the moon and back, and then also around the moon and on the surface of the moon to explore space and the moon further, basically. Now my computer decided that the power level is very low, so thankfully we just finished. I want to mention that we're having a conference at the beginning of May, so please inquire with me in understanding more about the conference coming up in May. There are actually available seats and speaking places for those who are wishing to speak. Then also we are having several webinars coming forward. There's a next one, Lunar webinar, around the middle of April again. So I'm going to invite you again. I wish you to be there. let me just thank, as a last minute, a few seconds, the sponsors of this webinar, Comstar Space Communications and Thales Alenia Space. So thank you very much for sponsoring, at least to recover the costs of this webinar for the tools that we're using. Thank you very much. And for those that are interested in knowing more about the Access.Space, please inquire with myself or just go on the website, and then you can decide if you want to join us or not. Thank you very much, everybody. Good luck. Stay safe.
Take care. Bye-bye.
Bye.
Thank you. Bye-bye.